In this video we'll take a look at problem number 7 from out of section 2.8. A few people were asking questions about this one in class, so I thought I'd put the solution on YouTube for you. If we're looking for the derivative of any function or relation that has a square root in it, we realize at this point that we need to get the root out of there and get exponents in place of it. So this is a pretty common thing that we've done over the course of the last month or so. And then when you're doing a derivative implicitly, since y is not solved for in this equation, we're just going to dive right in and take the derivative of each side with respect to x. So we're doing the derivative of this entire side of the equation with respect to x, and we're also going to do the derivative of this side with respect to x. So the derivative on this side, and sorry that got a little sloppy, the derivative of 12 is going to be 0. So we have, half of this equation has a nice simple derivative, not really half by amount, but the one side of this equation has a nice simple derivative. And then the derivative over here is going to be one that we're going to have to kind of be a little more careful with. So the derivative of the quantity xy raised to the 1/2 power is going to require the chain rule, because we have an inner function xy and an outer function something to the 1/2 power. So the chain rule says do the derivative of the outer function, and the derivative of something to the 1/2 power is going to be 1/2 something to the negative 1/2 power, and the something is the same inner function that we started with, so x times y. And then here we need to multiply by the derivative of the inner function. We need to multiply by the derivative of xy. Now, y is a function of x whenever you use implicit differentiation. So we have a product of two functions of x right here. So we're going to have to use the product rule to take this derivative. And because I'm multiplying by the derivative of xy and needing to use the product rule to do so, I'm going to need this set of grouping symbols so that I'm sure that this entire first portion of the chain rule is multiplied by the entire second portion of the chain rule. The derivative of the inner function right here is just going to require the use of the product rule. And the product rule says take the derivative of the first function, multiply by the original second function, and then add to that the original first function times the derivative of the second function. And the derivative of y with respect to x is dy dx. The derivative of this next piece, the minus 4y squared, well, y is a function of x. So we have an outer function, minus 4, something squared, and an inner function, y. So we're going to have to use the chain rule to take this, and the derivative of minus 4 something squared is going to be minus 8 something to the first, and the something has to be the same inner function that we had back here, which was y. And then we finish the chain rule by multiplying by the derivative of the inner function. Multiplying by the derivative of y will cause us to have to multiply by dy dx. And then finally I could tack on the derivative of the other side, which we specified a couple minutes ago, to be 0. This is not very nice looking. We want to try to solve this equation for dy dx, so that as an end result we're saying the derivative of this relation is equal to this, and then we could use that derivative to find slopes of tangent lines up against the relation and everything that we've been doing with derivatives for the last month. So I'm going to clean this up a little bit. I have this one term out here outside a set of parentheses that contains two terms. And I don't really like the fact that I have a negative exponent here, so I'm going to do a little bit of algebra. Like I'm going to move this xy across the fraction bar into the denominator with the 2, and then I'll be able to change the sign on the exponent to a positive 1/2, and if it's a positive 1/2 you can change it back to a root. So the term out in front of the parentheses is this. I'm going to clean up the parentheses a little bit. I have all these extra grouping symbols here just to kind of denote where my pieces of the product rule were located, but they're not really doing anything other than visually making sure that we did all the components of the product rule we were supposed to. And then this next piece doesn't really clean up too much. And then I still have 0 on the other side. So it looks a little nicer now that I've touched it up a bit, but we want to try to solve this equation for dy dx. We have a couple dy dx's in this equation, one of them here, one of them here. I can't really move this or this over to the other side very easily because of this set of grouping symbols and the fact that I'd have to distribute that into both pieces. So I'm going to go ahead and do that. Like these two fractions right here are both over 1. So whenever I do the distribution, top times top is going to give me y, and then bottom times bottom is going to give me 2 square root of xy. And then if I distribute into the second piece, 1 times x dy dx is going to leave me with x dy dx. And then bottom times bottom is going to leave me with 2 square root of xy. Still have minus 8y dy dx here. And it's still equal to 0. At this point, I could subtract this from the other side of the equation to move it across the equal sign. I could then factor a dy dx out of the remaining 2 terms as a common factor. I could divide by whatever's in that set of parentheses, and then I'd have my derivative. Now if you're thinking through those steps, if we move this over here and then we divide by something else, we're going to have fractions within fractions, and typically that's something we don't like to see happen. So what I'm actually going to do here is I'm going to clear my fractions. I'm going to get rid of the fractions, and this is, you know, kind of optional, but I just want to show you how we can make this match up with what you're going to see in the back of the book. So I'm going to clear my fractions by multiplying each side by that denominator. Oops, kind of got off the screen there. So I'm going to multiply each side by 2 square root of xy, and I'd have to multiply this side by 2 square root of xy. And that's simple because that side's a 0, so that side's going to, you know, remain a 0. And then if I distribute this into all 3 pieces, you know, this and this would cancel, and I'd just be left with y on the first term. Same thing on the second term. This is going to cancel with that denominator, and I'd be left with x dy dx. And then I would distribute it into the last term, and yeah, I end up with a little bit more on this last term. I can multiply these numbers together to get a 16. And then I'd have square root of, and I'd have a y outside of the root, so I'll copy that in first, and then I'd have my square root of xy, and then my dy dx. And if I'm trying to solve this for dy dx, now it's more similar to a lot of the other ones we've looked at. I can move my y to the right of the equation, so I'd subtract y from each side to move this across. My only 2 pieces left over here would then contain dy dx, and I could factor dy dx out as a common factor. So if I take dy dx out of the first piece, I'm left with an x. If I take it out of the second piece, I'm left with all this stuff. And then dy dx is going to end up being equal to the negative y that's already there divided by this set of parentheses. And this should resemble what you see in the back of the book pretty closely. So like I've been saying pretty frequently over the last couple weeks, you might not do a problem and have it match with what's in the back of the book, but what you have on your page might very well be a valid form for a derivative. There's just some simplification that took place that you maybe didn't think to do that the people who put the solutions in the back of our book actually did do to write down a nicer solution. So hopefully this helped. If you have any questions or you'd like me to check any of the problems you try on this or anything else because it's not matching up with what's in the back of the book, feel free to stop in and I'll check it out for you.